in problem number 5, we've got 4 coins and we toss them, and the question asks, what's the probability that at least 2 heads will be showing? So, probability, we're just looking for, so if we write probability is equal to the number of desired outcomes. So it's, in this case, the desired outcome is at least 2 heads divided by the total number of possible outcomes. So total possible outcomes. Okay? So really, probability is just 2 counting problems. We're counting the number of ways that we can get at least 2 heads, and on the in the denominator we're counting the number of ways, the total number of ways that the coin toss could come out. So actually the easiest part of this problem is the bottom, is the denominator. So let's do that first. So we're looking for the total number of ways that these 4 coins could come up. Now I could list them all out, but of course there's an easier way. So the total possible outcomes is just, we have 2 possibilities for the first coin, 2 possibilities for the second, 2 for the third, and 2 for the fourth. So it comes out to be 16. And if you want to see that visually, you could draw a tree. So you could, on the first coin, you could get a heads or a tails. And on the second coin, you could get a heads or a tails, or a heads and a tails, right? So for the first 2 coins, we could have heads, 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 tails, heads, or tails, tails, right? So there's 4 possibilities, excuse me, so far. And then again, for each one of these possible outcomes, there's 2 more, okay? So you can see we go from these 4 possible outcomes to doubling it. So suddenly we've got 8. So we get heads, tails, heads, tails, heads, tails, and so on. And then we've got 1 more coin to toss, so that's going to double the number of outcomes again. This gets kind of messy to draw all these. But you get the idea. You start with 2 and you double it. So you get 2 times 2 times 2 times 2. So you end up with 16. So that's why we multiply right here. Okay. So that is the total number of possible outcomes. Now, the trickier part is the top, the numerator, the number of desired outcomes. So let me scroll down just a bit here. Now, at least 2 heads means what? At least 2 heads. That can mean 2 heads, it can mean 3 heads, or it can mean 4 heads, right? So we can have any of those cases, and that would qualify as at least 2 heads. So we could do it that way. We could figure out how many ways we could get 4 heads. Well, there's only one way to get 4 heads, right? It's just head, 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 head. You can kind of see it in the tree right here. Head, 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 head. So there's only going to be one way to do that. We count the number of ways that we can get 3 heads and the number of ways that we can get 2 heads and add them all up. So why don't I go ahead and do that? That's probably the most direct way, but there's actually an easier way too. So I'm trying to decide whether I should give it the easy way first. But let me go ahead and just do that. Okay, so if we do case 1, we have 4 heads. Okay, I'm going to count how number of ways. So it's only one way. It's just head, 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 head. So there's one way to get all heads. Case 2 is 3 heads. Now, that could look like head, 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 tail. But if you take a look at that, there's just one tail. So getting 3 heads is also getting one tail, exactly one tail. And there's only 4 places where that tail could go, and then the rest would have to be heads. So there's 4 ways to get 3 heads. Okay? You see what I'm talking about? So getting 3 heads is the same as getting one tail, and there's 4 places to put that tail. So there's 4 ways. Case 3, where we're looking for 2 heads, that's a little trickier. So we could list those out. You could get head, head, tail, tail. You could get head, tail, head, tail. You could get head, tail, tail, head. Let's see. I think that takes care of all the ones with a head first, right? And so then let's go on to tail, head, head, tail. Scroll down a little more here. Let's see, let's start with the tail again. Tail, head, tail, head. And we'd have tail, tail, head, head. Okay? So I think that's it. I think that's all we can do. We got 3 cases with a head first, and 3 cases with the head with a tail first. So if we add those up, we have 6 ways. And when I add up, whoops, get rid of that. So if I add those up, I get 11 ways to get at least 2 heads, and we had 16 ways, 16 total possible ways. So the probability would be 11 out of 16. Okay? So that's one way to get it, and that is the answer. So let's see if we can find an easier way to do it. Now we're looking for at least 2 heads, but the complement, let me write that out, complement of that, now notice I spell it with an E here. So it's not complement. If it was complement, yeah, let me erase that. That should look like an N. Complement, this is like, with an I, it means like, oh, I like your shirt. You know, you got a really nice shirt today. Your hair looks really good today. You know, that's some sort of praise. But when it's spelled with an E, it means something different. It means the complement is something that completes. So for example, when we have a complementary angle, it completes. So the complement of 30 degrees is 60 degrees because it completes a 90-degree angle. Okay? And so in this case, when we're talking about probability or counting, we can count the complement of at least 2 heads, and the complement of at least 2 heads is that we have less than 2 heads. So the complement is less than 2 heads. And that's because if we took all the cases where we have less than 2 heads and we added all the cases where we had at least 2 heads, we would get all the possibilities. Okay? So this is the complement of this case where we have at least 2 heads. So if we count the complement and subtract it from the total possibilities, we'll actually get what we're looking for. Okay? Does that make sense? And sometimes it's easier to count the complement. Like, for example, in this case, less than 2 heads is either 0 heads or 1 head. And those are easier to count than all 3 of these cases up here. So let's do that. Let's count the complement and then subtract it from the total possibilities. Okay? So let's do the case where we have 0 heads. Okay, and 0 heads just means it's tails, 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 right? So there's one way to get that. And 1 head, it's just going to be all tails except for 1 head. And just like up here where we had the case where we had 1 tail, to get 1 head we've only got 4 places to put the head, so there'll be 4 ways. Whoops, I'm not writing very well this morning. So there's 4 ways to get 1 head. And if we add those up, we get 5 ways. Okay, and that's the complement. So we knew that there was 16 total possible ways. If we subtract 5, we get 11. So there's 11 ways to get at least 2 heads, okay? Because less than 2 heads is the complement of at least 2 heads, okay? So again, we get there's 11 ways to get at least 2 heads. And when we compute the probability, again, it's just equal to 11 out of 16. Alright? So that's something to look for when you're doing counting problems, is that sometimes it's easier to count what you don't want than it is to count what you do want, like it is in this case. It's a lot easier to count the number of ways to get 0 heads and 1 head than it is to count the ways to get 3 heads, or 4 heads, 3 heads, and 2 heads up here. Okay? So, something to keep in mind when you're doing counting problems. But either way, the answer is 11 out of 16.